Hello and welcome everyone. This is a small presentation in which we shall learn the problems on quantitative techniques, and this is designed especially for MBA first semester PU. And today we have taken a problem on the Bayes theorem, and this is very important for the examination. It always appears in the examination, and we have taken a question from the textbook. The question goes like this. An insurance company insured 2,000 scooter drivers, 4,000 car drivers, and 6,000 truck drivers. The probability of accident is 0.01, 0.03, and 0.15 respectively. One of the insured person meets an accident. What is the probability that he is a scooter driver? So let's understand the problem. First of all, we have given that there are 2,000 scooter drivers, 4,000 car drivers, and 6,000 truck drivers. So these are also called the exhaustive events. Means in this insurance company, the total number of people who insured are 12,000. And further, we have given the probability of accident is 0.01, 0.03, and 0.15 respectively. So they are the chances of happening accident. 0.01, this is the chance of meeting an accident by the scooter driver and similarly 0.03 is the chance of meeting an accident by the car drivers and similarly 0.15 means this is the chance of meeting an accident by the truck drivers. So 0.01, 0.03, and 0.15, they are called prior probability. They are called prior because this information we have already known before meeting an accident, and this is possible from the past experience. The past experience, the insurance company knows about this figure. And now further we have given what? One of the insured person meets an accident, and now an accident has taken place. An accident has taken place, and then what is the probability that he is a scooter driver? So here we have to understand that the accident had already taken place. Accident has happened, and now we want to know what is the chance that the person who has met an accident is a scooter driver. We know that a scooter driver may meet an accident, or truck drivers may meet an accident, and similarly a car drivers. But we are asked what is the chance that the scooter driver, given that the accident has already occurred. So accident is the first event. Happening accident is the first event, and we want to know what is the chance that uh, the insured person who meets an accident is a scooter driver. So first of all, let's summarize this problem by writing in short form. So now here, sorry, here let events A1 represents scooter driver, A2 represents car drivers, A3 represents truck driver, and also let event E is equal to an insured person meets an accident. And please understand, uh, so here the accident can be met by either scooter driver or car driver or truck driver. So now there are several methods for solving this question. I will show you at least three methods for solving this question, and you will decide the easier method by yourself. So now the first method is based upon tree diagram method. According to tree diagram method, before we use the tree diagram method, now we are writing the information. So first of all we are writing PA1. So how can we read it? This means probability of selecting a scooter driver. What is the chance that a scooter driver may be selected? So here we write, okay, we know that there are 2000 scooter driver and total number of drivers are 12,000. So what is the chance that a scooter driver may be selected? 2000 divided by 12,000. 2000 represents the number of favorable outcomes and 12,000 represents the number of total possible outcomes. And so by reducing in the simplest term, we may write 1 by 6. And similarly, we have to write PA2. So you can read PA2 like this: probability of selecting what? Selecting a car driver. So can you guess what would be the probability? Of course, 4000 divided by 12,000. By simplifying, we get 1 by 3. And similarly, probability of selecting a truck driver. So we know from here, truck driver 6,000. So 6,000 divided by 12,000. Now 1 by 2. And now please understand, they are called what? They are called mutually exclusive events and also exhaustive event. Mutually exclusive means both cannot happen simultaneously. Any of these three cannot happen. Any of these two or all the three cannot happen simultaneously. So they are mutually. So either or scooter driver will meet an accident, or car driver will meet an accident, or truck driver. We cannot say like this, a person met an accident and he is a car driver as well as a scooter driver. No, it's not possible. So they are called mutually exclusive events. And further, why it is called exhaustive? It is called exhaustive because it is complete. If you add 1 by 6, if you add 1 by 6 plus what? 1 by 3, 1 by 3, and similarly plus 1 by 2, then we get how much? Then we get 1. So 1 means what? 1 means total probability, and that's why this is called exhaustive. Exhaustive means complete, nothing is left. And let's see. So I want to erase this. Okay. And further, and similarly, we have to write like this: PE/A1. What does this mean? This means P stands for probability of meeting an accident given that he is a scooter driver. He is a scooter driver. So this simply means that what is the chance that an accident will be met by scooter driver? And you know that here we have given 0.01. 0.01. Similarly, what is the chance that an accident will be met by a car driver? Of course, 0.03. And what is the chance that an accident will be made by a truck driver? So we know 0.15. 0.15. And now then after we're going to draw a tree diagram. So in this tree diagram, first of all we write first event, then we write second event, and then we write combined event. So let's understand what do they mean. So first event means either an accident can be made by either scooter driver or car driver or truck driver. So A1 means what? The A1 is the event of the scooter driver, A2 a car driver, and A3 is our what? A truck driver. So now, what is the chance that a scooter driver will be selected? The chance that a scooter driver may be selected is PA1, PA1, and here we write PA2, and then we write PA3. So, so from the previous slide, we know that PA1 is equal to how much? 1 by 6. From here, please note from here, 1 by 6. And PA2 is equal to 1 by 3. And PA3 is equal to 1 by 2. So they are the individual probability of meeting an accident by the scooter driver, car driver, and truck driver. And further, we are going to write the second event. A second event means now the accident will occur. So what is the chance that a scooter driver will meet an accident? And now at this point we have to understand, it is not necessary that the person will meet an accident. The person will or will not meet an accident. So this is the one possibility. E means what? An insured person will meet an accident. And here again we draw one line. This line represents E bar, E complement. E complement simply means non-happening of accident. E means happening of accident, and E complement means what? Non-happening. So I want to ask from you. Okay, in this problem, an accident has taken place or not? So by reading the question, we know that the accident has already taken place, and therefore this line is not important. This line is not important, right? Why this line is not important? Because in the problem the accident has already occurred. So this line is important. Now, so now we are going to write like this: PE slash A1. PE slash A1 means what? Probability of accident made by whom? The scooter driver. So in the same way, we can write the pair lines from each branch. So here we write PE slash A2, and here PE slash A3. And now, so let's understand further. So let's write down these values. So 0.01 comes from here, 0.03 comes from here, and 0.15 comes from here. Okay, and then after, and here we can see that the vertical two lines, there are vertical lines. What does this mean? This means they are closed path. Closed path means we are not going to calculate this its value, because E complement means non-happening of accident. But in reality, as a matter of fact, the accident has already taken place. So it is not important for us. And now we are going to calculate the combined event. What is the meaning of combined event? Combined event simply means that uh, what portion of total accident will made by the scooter driver. So this is called the simultaneous chances of meeting an accident by the what? Scooter driver. And similarly, the simultaneous happening of accident by the car driver. And similarly, the simultaneous chance of happening accident by the truck driver. So let's understand from where this figure has come. From where? So this figure has come by multiplying 1 by 6 and another 0.01. So by multiplying these two, we get P A1 and E is equal to, so here we can add this formula, P A1 multiplied by what? P. So this is the end statement. You know, in end statement we have to multiply. So by multiplying these two, we have get this information. And furthermore, 0.01. 0.01 is the multiplication of 1 by 3 and 0.03. Similarly, 0.075 is the multiplication of 1 by 2 and 0.15. And after calculating all this, and now we are going to find what is the total chance of happening accident made by whoever the person, whether he is a scooter driver or car driver or the truck driver. So here P stands for what? P stands for the total probability. What is the chance that an accident will happen? So please understand. So we say an accident will happen in the condition where either truck driver or car driver or scooter driver will meet an accident. So this is called total chances of happening accident. In another language, we may also say that this is total possible outcomes of happening accident. Total possible outcomes, and this is called number of favorable outcomes. Number of favorable outcomes here. So I think you are getting it. And now suppose we want to ask the requirement like this. What is the chance that, suppose one of the insured person has met an accident, and what is the chance that he is a scooter driver? So this means what? This means favorable outcomes. This is the chance that a scooter driver will meet an accident, and this is favorable outcome, and this is the total possible outcomes. So how can we calculate? We can calculate the required probability like this: 0.001667 divided by 0.086667. So let's see. So yeah, probability that the insured person who already meets an accident is a scooter driver. So how can we write this information? Let's understand. So here, insured person who already meets an accident. So meeting accident, it is the first event. So E means what? First event. And he is a scooter driver. Scooter driver means A1. So we write like this. We write like this. P stands for probability. A1 means scooter driver, and given that accident has already happened. So please understand, we should not get confused. We should not get confused about this symbol. About this symbol P A1. Sorry, not A1. P E slash A1 slash A1. Now understand. Uh, Here PE slash A1. This means what? This means the chance that an accident will be made by what? Scooter driver. The chance that an accident will be made by scooter driver. This is called prior probability, right? And this is called what? This is called posterior. Posterior means after the accident, after happening accident. Posterior. So the accident has taken place, and we know that the three different types of driver can meet an accident. So accident has taken place, and now we have to find the chance that, what is the chance that the person who met an accident is a scooter driver. So I think you have got this point. So here right now we are going to write the answer like this: PA1 and E divided by PA. So what does this mean? This means that this is the favorable outcomes. This is the favorable outcomes. This one, this is the favorable outcome, and this is the total possible outcomes, like this. So here we write 0.0167 here, and then here we write 0.8667, and then the answer comes to 0.0192. The answer comes to 0.0192. So I think you must have understood, and this is the first method.